Okay, so now I will draw just the absolute value of x in two different things. So I'm just going to draw it based on the longer way, by definition of an absolute value, drawing by writing out a composite function, and then the shorter way by just using my summary and what I know about absolute value graphs. So longer way. We know that absolute value x means that it's x whenever whatever's inside, which is in this case just x, is positive, and it's negative of whatever's inside, so negative x in this case, for when whatever is inside is negative, and I can include the positive part there. So if I draw this, it's two lines. It's just y equals x and y equals negative x. Okay, so I can go ahead and say y equals x is going to be like this with a slope of 1, so it goes through the point 1, 1. Y equals negative x is just going to be like this. It goes to the point negative 1, 1. And the reason I stop them both at the origin is this thing exists, this positive one, from including the origin all the way up. It doesn't exist past this, it only exists for positive x. This one only exists for x that is smaller than 0, so excluding the origin to the left. It ends up being like that. If I use my quicker method, I can analyze this by saying, what does the number in front do? Okay, it determines if it's a positive or a negative. This is plus 1, so I know it's going to be V-shaped like this. Next, what is the number in front here? Well, 1, and in front of my x, 1, so the gradient, if I multiply those two, is 1, so I know it's going to be 1 to the right, 1 up, it goes through the point 1, 1. Okay, now, where does the graph actually start? I skipped to going through, it goes through the point 1, 1 already. First, I need to determine where does it start. Did I move to the right? No, there's nothing added. Did it move up or down? No, there's nothing added. It starts at the origin. Then I can go 1 to the right, 1 up. So I can draw it like this. Okay, it is symmetric from the point where it starts. Okay, so it starts from nothing got added, so 0, 0. So it's symmetric from here. So if it went 1 to the right, 1 up, it should go 1 to the left, 1 up, and go through there. If this method of analyzing and drawing it like this is harder for you, stick to this method. We'll see now what the effect is when I add something. So let's quickly do a graph like y is equal to x plus 2 minus 3. Okay, so firstly, let's draw it as a composite function. So composite function, we know that it's what is inside, keep it positive, for whenever what's inside is positive, and what is inside becomes negative whenever the thing inside is smaller than 0. So if I solve this, it would just be x minus 1 for the top one, for x greater or equal to negative 2, and this would be minus x, then it would be minus 2 minus 3, so it's minus 5, for, in this case, x smaller than minus 2. Okay, so I can go and draw those two graphs if I really wanted to. So if I wanted to, I know y is equal to x minus 1. It means it has a y-intercept at minus 1. It's got a positive gradient of 1, so it would go through 1, 0, like this. So I already know it exists like this, and it only exists for greater than negative 2. So from negative 2, so I know it would go through here, go through negative 1, negative 2, I'm just following the slope, and it would start from here. Okay, so if it starts from there and it goes through there, there's my positive graph. Okay, the negative graph has a negative slope of minus 1, and it goes through minus 5 theoretically. It wouldn't actually intersect, but if I were to continue the line past this, it would intersect here at minus 5. It doesn't in this case. I can either draw a table to draw this, or I can analyze this again. No, it starts from this point as well, because if I substitute in negative 2, I get negative of negative 2 is going to be positive 2 minus 5 is going to be minus 3. And guess what? This is at minus 3, minus 2, minus 3. Good. So it does start from here. Just substitute in minus 2 and you'll see you get a y value of minus 3. It does start from here. Okay, now what does the gradient of negative 1 mean? It means 1 to the left, 1 up. So if I go 1 to the left to negative 3 over there, sorry, let me just write this properly, and negative 2, which would be approximately here, and then I can just draw it. Obviously, you draw nicely to scale, extend the thing all the way, but you can see it would have a shape like this. Now, let's draw it in the quicker method. Okay, so the quicker method, not necessarily that much quicker, but I don't have to do a whole composite function and try and draw 2 separate graphs. All I need to do is to ask myself, what do I know about this? Well, what I know is it's y is equal to, and it's x plus 2 minus 3. Okay, what do I have in front here? It's a positive, so it looks like this. Okay, what do I have in front there? It's a 1. What do I have in front of the x? It's a 1. So the gradient ends up just being 1. Okay, so my gradient is 1. It's a positive thing, so it has this shape. Now to determine where it starts. X plus 2 means it moved 2 to the left. So if I go to the left by 2 units from the origin, it's negative 2. It also went 3 down. Minus 1, minus 2, minus 3. 2 to left, 3 down. So at the point minus 2, minus 3. Minus 2, minus 3. There it starts. Okay, now it has a positive shape like this. Gradient is 1. So every 1 unit to the right, I go 1 unit up. So it goes through the point negative 1, negative 2. And then it goes through negative 1, which we got as the y-intercept there. So it beautifully follows our pattern that one did already. I draw it and then I say, well, this is an absolute value graph. So it's just going to be the symmetrical reflection of this basically. So I know it's going to start from this exact same point, but now the slope is going to be 1 to the side, 1 up. And I can draw it. And you can see both graphs look the same. So by analyzing, I can see I look at my gradient. I say it started from the point 2 to the left, so minus 2, 3 down, minus 3, minus 2, minus 3. Both start from the same point, exactly the same graph. Okay, I'll do another video where I draw one that has a negative slope and something in front of the absolute value and in front of the x, just so you see every single element. And I draw it in both ways, so again, either way is going to be fine. This is just extra info.